Okay, let's talk about the sum and difference formulas. On your note card in front of you, you have the 4 different formulas. Sine of A plus B is equal to sine A cosine B plus cosine A sine B, and so forth. I'm going to work the examples. You need to be looking at your note card so that you can see the formulas. Example 1. So we have this problem here. It says the sine of 30 plus 135. Now, if you were using your calculator, you could add 30 to 135 and you have 165, and you could type that in and it'll give you a decimal. We don't want decimals. We want to be able to use our trig value charts to come up with these solutions. And so what we do, the idea behind these formulas is so that we can use our trig value charts to come up with exact answers. Remember that on our trig value chart we have a lot of reduced radical answers, and those are exact answers. If we were to get the decimal approximation, those are irrational numbers and they're not exact answers. So the reason we would use these sum and difference formulas of sine and cosine is so that we can use our trig value chart to come up with exact answers. So this is how this works. First of all, I need to see that this is the sum of 2 angles inside the sine functions, and so I would use the sum formula for sine, and that is this right here. I'll recopy it from your note card so you'll see what I'm talking about. The sine of A plus B, and the formula is sine A cosine B plus cosine A sine B. So what we want to do here in this problem, hopefully it's easy to see, that we'll say that A is 30 and that B is 135, and I just simply plug this in. So I have sine A, which is going to be sine of 30 degrees, or these are in degrees, and then times cosine B, which is 135, so that's cosine 135, plus cosine A, which is going to be cosine 30, times sine B, which is going to be sine 135. Then what I need to do here is use my trig value chart. You have that in your note card notebook, and I want to just use that to find these values. The sine of 30 degrees is 1/2. So I have 1/2 times the cosine of 135 is negative root 2 over 2. Plus the cosine of 30 degrees is root 3 over 2 times sine 135 is root 2 over 2. And now, not using a calculator, I have to simplify this. So remember, what I want to do using my order of operations, I'll do this side and then I'll do this side, then I'll add those two things together. So I have multiplication, 2 fractions, so it's top times top and bottom times bottom. So that's 1 times negative root 2 is negative root 2 over 2 times 2 is 4, plus root 3 times root 2 is root 6. Whenever you're multiplying radicals, as long as the index number, which in this case is going to be 2 because these are square roots, as long as the index number is the same, we can just keep the radical on the same index number and multiply the radicand, which is a number underneath. So this becomes root 6, and then 2 times 2 is 4. Then I want to add these fractions. Good thing is I already have a common denominator. My common denominator is 4. So I have negative root 2 plus root 6 is negative root 2 plus root 6. And the only way I can add radicals is if my index number is the same and the radicand is the same. My index numbers are the same, but my radicand's the number underneath is not. And so I'm done right here. This is my final answer. So this is when you have the sine or cosine of the sum of 2 angles or the difference of 2 angles. All you would do is pick which formula to use and then just plug those numbers in. Use your trig value chart to come up with those answers and then simplify. take a look at example 2. So here we're going to work backwards. You should see that, well, we have one of our formulas here. So let's see which one is going to be sine, cosine, minus cosine, sine. And looking at my note card, that's going to be the difference sine formula, because that one is sine, cosine, minus cosine, sine. So what I'm dealing with, if you look at your note card, it's the second formula. This is sine A minus E. Again, the way I did that, or how I did that was I was looking at which formula on my note card does this thing look like. And this one is sine A, cosine B, cosine A, sine B. And that's what we would have to do next, is identify and from our formula that A is going to be 65 and B is going to be 5 because of the place that where they're at on your note card. And so what I have here is sine A, which is 65, minus B, which is 5, which gives me sine of 60 degrees. And looking at my trig value chart, that's root 3 over 2, and that's my answer. So when you're given the sum or difference formula with angle measurements already in like this, you work backwards. And they're typically pretty easy. Let's look at another example. Example 3, we have cosine of 165 degrees. Here what you have to do, this is really what these, a big reason of why we even have these sum and difference formulas, is because if we have this cosine of 165 degrees, again, if we type this in the calculator, it's going to give us a decimal, and there's no way of really finding the exact answer. But what I can do is I could say, okay, well, can I find a cosine sum or difference so that I can either add two angles that are on my trig value chart to get 165 or subtract two angles to get 165. Two angles for me come to mind, and typically there's more than one way to do these. Sometimes there's only one way, sometimes there's more than one. What I see here is cosine of 120 plus 45. And the reason I'm using these two is because 120 and 45 are both members of my angle families for my unit circle that are on my trig value chart, and also they add to 165. So I've got a cosine sum here, and my formula for that is going to be, I've got cosine A plus B is equal to cosine A times cosine B minus sine A sine B. And in this case, hopefully it's easy for you to see that 120 will be A and 45 will be B, and I just plug it in. So I have cosine of 120 times cosine 45 minus sine 120 times sine 45. And using my trig value chart, cosine 120 is negative half. Cosine 45 is root 2 over 2 minus sine 120 is root 3 over 2, and sine 45 is root 2 over 2. And so I do my multiplication first. Negative 1 times root 2 is negative root 2 over 2 times 2 is 4 minus root 3 times root 2 is root 6 over 2 times 2 is 4. I'm going to subtract, need a common denominator. That common denominator is 4. So I've got root 2, negative root 2 minus root 6, and that's my answer. Because I can't subtract these because my radicans aren't the same. That is my simplified answer. Let's move on to example 4. Okay, what we want to do here, you might get a problem like this and I might tell you to simplify it. So what you have to do is recognize that this piece on the left hand side is the sum of a cosine, and this piece on the right hand side is the difference of a cosine. And in each case, respectively, pi thirds would be A, well, I say respectively, but they're the same, and B is going to be X. So over here, A is going to be pi thirds, and again B is going to be X. And I need to figure out what I have here. Well, if I have the sum of a cosine here, this one, the piece on the left, using my note card, becomes cosine pi thirds times cosine X minus sine pi thirds sine X plus, and this plus is that plus right there. This right side becomes, this is a difference cosine, so this becomes cosine pi thirds times cosine X plus sine pi thirds sine X. Now I use my trig value chart to simplify what I can. This piece, this piece, this piece, and this piece can all be simplified to some number using the trig value chart. So I'm going to do that. Cosine pi thirds is 1/2. So this becomes 1/2 times cosine X minus sine pi thirds is root 3 over 2 times sine X plus, again, cosine pi thirds is 1/2 times cosine X, and then plus sine pi thirds is still root 3 over 2 times sine X. Now what we have are some like terms. I have half a cosine X plus half a cosine X. That gives me a whole cosine X. Again, half cosine X plus half cosine X becomes a whole cosine X. So those are gone, so I'll just mark those out. I'm finished with those. Here I have a minus root 3 over 2 sine X and a plus root 3 over 2 sine X. So those just cancel each other out. And so what I'm left with is cosine X. So my answer is this thing up here, cosine pi thirds plus X plus cosine pi thirds minus X, simplifies to cosine X. So what we have to do with these types of problems using the sum and difference formulas is see if I need to work backwards. See if I need to find two angles that either add or subtract to get to a specific angle, or simplify using, and all the time using my trig value chart and basic simplifying techniques. Let me